Hey, what's going on, folks? It's Mike here, and welcome back to my Modern C++ series. In today's lesson, we're going to be talking about cout. Do we even know what that stands for? And what do we need to know now that we've got C++ 23's print functions? So if you didn't catch those print function videos, go ahead and check those out. But let's go ahead and dive into cout, something that most C++ programmers know, especially if you've learned C++ in the last few years. So anyways, let's go ahead and scroll down here to the input-output library. Now again, as mentioned, there are print functions available in C++. Let's go ahead and zoom in on that a little bit here. And just to give you a little refresher of the print functions, let's go ahead and just remind ourselves what we did here. So again, I'll go ahead and put those into focus here. The print functions, these are print and print line. And you're going to need to include the print header, okay, as displayed here. Okay, so let's go ahead and define print. And I've got that set up here. And just as a reminder, you're going to need a relatively recent version of G++ or Clang++ or Microsoft Visual Studio, whatever compiler you're using, because this is a C++ 23 feature. Okay, so let's go ahead and do standard print line. So we get the end line for us. We can do hello world. There's one version of it. And of course, we get the formatters where we can have these placeholder here for our arguments. And I'll just put hello here just so you can see that, again, if we compile this using C++ 23 here, let it compile and run, we get the same thing here. Okay, it does the textual substitution. And we talked about last time how this is an advantage, this sort of C++ 23 way of doing things versus the C style bad, unsafe, type unsafe here, type unsafe way. If we do like standard print f, for instance, with a format specifier, an end line, it's a little bit more clunky too, but it's manageable. And of course, if you're doing C style programming, you have to use the C style API. So let's go ahead and compile that. And this should be in the C stdio library here, which I believe is already just included implicitly. And anyways, there you get your hello world here. So we tend, so I should say, as C++ programmers, tend not to do things this way now. Might be, let's say might be, okay, again, if you're in a C world, there are always reasons to have these functions available, but again, we're going to do things the modern way. And again, print line with the format specifiers, usually fine for us. And again, the jury's still out. A lot of folks have tested this and have said this is really good here. Now, what about the C++, 98 or older, I should say, to now with standard cout here? Okay, so what about this version that we have here? Standard cout hello world here. Okay, let's try to understand this, what's going on. Let's compile it. Let's run it. And there you go. Now, many of you, if you've learned in a university, a textbook, are still going to have this example here, right? I'm recording this video in 2024, so C++ 23 is just getting, its features implemented, and, you need to make sure you have the latest compiler, and not everybody's up to date with that. And again, as a reminder, if you can't follow along with these examples on the terminal, feel free to open up Godbolt or Compiler Explorer, and you can follow along there with the latest version of these compilers. Alrighty, so anyways, why should we know about this here? Okay, so what is cout first and foremost? Well, first and foremost, let's go ahead to the Cpp webpage, and we're going to go to stream-based I/O here. So let's go ahead and click on this, stream-based I/O. And actually, I have this open already. Let's just start from the top here. And I want to kind of compare it with our print functions here, with like print here, where I do have the ability to print to standard output or file stream, for instance. So I can do a lot of the things I can do with print that I can do with cout, right? What I mean by printing to standard output, which is labeled here, that is usually your terminal, wherever you're directing your output to. Okay, this would be an example. We could direct output to a file, for instance. We could direct output maybe to a string, for instance. And that's where the idea or the takeaway is that I want for the stream-based I/O for you today. Okay, so let's go ahead and open this and try to understand where cout lives here and just my thoughts about it. So again, C++ includes the following input-output libraries: an OOP-style stream-based I/O library. Okay, and then we've got the print-based function families, which I showed you here, print line, since C++ 23. And then, of course, you've got your standard C-style I/O functions. Again, there might be, reasons to include this. Maybe you want like a really small binary size, and you just want to include like, whatever this depends on. Might be just like the standard library. Again, there might be reasons or to have printf, or you're just used to it, or implementing with some C-style type or whatever. But again, we're probably, if you're using a C++ compiler, going to prefer one or the C++ 23 way or the cout way for output. Okay, so again, just throwing that out there. And if you have other use cases to argue why printf, please let me know. I'd be curious to have sort of the pros and cons there. But anyways, with streams here, well, we have this sort of API here. And again, we're forming a hierarchy here because we have different types here. Okay, so we want to understand just a little bit about how cout is structured in this video. And if I sort of start with my input-output base here, and then I say, okay, we've got some basic I/O types here. First and foremost, you'll notice char t is what's listed here. Now we can, of course, have wide character types, right, for things like Unicode or printing out, for other different languages that have different character sets. We have the wide versions of those. But that's why you'll see the char t here for most of these. If I sort of follow this down and just understand, because sometimes you'll see these in like template errors like basic_o stream or something, right? That's your output stream here. And then you can keep following it and see o string stream here. And then I've got o f for output file stream here. And I've got my other IO stream stuff here. And at least from the Unix sort of standpoint, output file to like the standard out, we sort of think about that like a file, and that's what I'm writing out to on my terminal here. Okay, so anyways, that's just sort of orienting us here. So there is some sort of hierarchy here for I/O, and basically what it's doing on the left side here, you can see we have output. On the right side, you can see we have iStream for input stream, so for reading in data from somewhere, maybe from a file, maybe a user. And then we've got the sort of combination, so an example of multiple inheritance of I/O stream, where you could do input and output. Okay, so anyways, that's just sort of how to read this diagram here. And that's why you have things like fstream, if you've seen that in tutorials, where you have a file that you can read or write from or something, versus like ifstream and ofstream. Okay, so now hopefully you understand some of these stream things. So anyways, I'm going to go ahead and kind of scroll through this because there is sort of this abstract device idea of where you can read and write data to, or do input and output, again, which is what a program is. So I'm going to kind of, we will touch on some of these things here, like string streams and so on here. But let's just get to the good stuff here, cout. And what I want you to see is here, we have these predefined stream objects here. We're going to be focusing on cout today. And again, we have the wide character version here. And then you've got your error handling and logging versions here. But let's go ahead and see cout here. So first and foremost here, I'll often hear folks say like a cout function or something. Cout, again, is an object. Okay, so it's defined here in the IOStream library here, because that's where cout is, and cin as well. And it's a global object. So we just have it available here, right? I didn't need to define anything. I just called cout. And then through an operator overload here, for all the basic types and things like literal strings or char stars, I'm able to send this into this cout object. So that's sort of the data that's being written into it. And then the stream takes care of, well, how's it processed? What do we do with this? In our case, it is just to write to the standard output, hello world. Okay, so that's a basic idea of what cout is doing. Okay, so global objects cout and wcout control output to a stream buffer of implementation defined type. Okay, so it's some sort of stream buff associated with the standard C output stream, standard cout. So again, we can take a look at this here. But this is basically cout. You have cout, cin, and standard error. So anytime that you start a process, you have ability to read in data, write out data, and also write data to some sort of error logging mechanism. Okay. Let's see here. So let's go ahead and knock that one out here. And then going through cout. So these objects here, cout, they're going to be initialized. Again, as I mentioned, you don't see any constructor call or anything like that. It sort of behaves like a function. Again, that's what folks think about it as. But again, I want to get it clear today that it is a object, okay, that we are working with. Okay, let's keep reading through this here. Let's see here. Okay, perfect. So the notes here that I want to highlight. What's the cout stand for? C stands for character. Out stands for output. So character output. Again, that's just what it means here, or wide character output. Okay. So that's the basic idea here. All right. So why do we care about this? What's, interesting about this? I mean, if I look at cout itself, right, it's just an object here. So really we need to look at OStream to see what are the facilities and some of the functionality of it. And why do we care about this versus printf? Or even print line. Again, I said printf we probably don't care about as much here, versus print line or just standard print, we need to make an argument for why even have this, in C++. Well, of course, for backwards compatibility, you can say you do get some power as far as, let me start making some of the cases for why here, for how you actually do your output. So you could do things like you could also do in print with different formats here. And basically what I'm going to show in this example here is if I create some Boolean value and set it equal to true, I can, in my stream of data, as I'm running this, I should put a little end line there, but you can see there's true. I can control the output here. Okay, and we could do that again with printf, so it's not a big selling point, but it's pretty clear how the data is being formatted. Maybe folks might like that. Okay, so maybe there's a preference thing. When it comes to the performance argument, we still have to measure these against each other a little bit here. Okay, so that's another discussion here. If performance matters, then you have to sort of change which one you're doing, especially if you're doing a lot of output to the console. Okay, so let's kind of list some of these things here. So similar format controls, maybe more verbose than standard print. Okay, so just kind of keeping those in mind here. So again, maybe not a big win for cout versus print line here. But we do get some flexibility in the data we're writing out, for instance. Meaning, let's go ahead and just kind of keep an eye on this. Meaning, with standard print, we really had to know or set up, at compile time, these sort of format strings here. Now, of course, compile time how, to format everything. So a little, more work using, print perhaps here. Okay, so what exactly do I mean by that? I'm just going to sort of summarize standard cout, very flexible. Okay, again, we can argue about what that sort of means here as far as how I can do this, but all I have to do here is basically create some stream object, overload the operator for the stream output. And again, what does that look like here? Operator like this. And that's basically it. Then I can just write out to cout or some object like that, and I can do whatever behavior I want here. Print is basically just going to, again, take the format. And again, there's ways you could use std format. There's ways you can create these arguments at runtime or compile time and print them out here. I just might argue it's a little bit easier. So let me just say summarize cout. I shouldn't say very flexible because it's not really more or less. You could probably do whatever you want. Probably easier to just use. Okay, you don't have to learn any weird rules or you know, how to format these things. And again, they're not that hard. You can watch my previous videos on that, but that's sort of the idea. So again, very similar to format controls, you know, but it's maybe more verbose, and it's got some sort of flexibility in how we're writing things out here, right? We can sort of turn things on and off. I'll put here, we choose when to flush, you know, partial data. So for instance, I can come in here and I can do a standard end line here, and I could just put a, you know, end character here. And the difference is standard end line forces a flush here. So forces a flush to our stream, because this is what's known as buffered output with cout. So it might write a little bit and then maybe write a little bit of data. And then when the operating system's ready, or after a certain amount of data has been written, then it will actually write out to the terminal or file or whatever your stream is. Okay, but you can use things like endline or explicitly flush here to do this. And let's just go ahead and demonstrate that. So again, just to prove that cout is an object, you could just call flush on it here, and we'll look at those member functions in a moment here. Oops, let's see here. Too many semicolons. There we go. So let's recompile that, and let's rerun it. And you can see again, you know, it works just fine here by making a function call, one of the member functions, on our cout object. Okay, so let's dive a little bit more in here. I mean, I hope this is going to give a little bit more clarity as to why we might want some sort of object-oriented output versus just a function call here by looking at some of the functions here. Because what I can do here is, well, I can basically do these unformatted outputs here, in which I just write a block of characters, or maybe write out one character at a time. So you can kind of build up some interesting abstractions on top of this. So let me kind of put that as the ideas here. With streams in general, we can build abstractions. They are objects. Okay, so that's sort of on the pro side if you're, you know, interested in that. The other interesting things that you can kind of do with, you know, having control over, you know, flushing the actual data and saying when you know, want to write it out here, you can do from your basic input-output, you know, stream types here, you could do things like check the states here. So you might want to know why something failed. I think standard print will give you error codes. In fact, we should look at that in a moment here. But you can see things like good, the reason why it failed, you know, check if you're at the end of the line, if you're writing to something. And again, these are facilities that support things like writing to a file mostly. But even for our regular outs to cout, you might not, and this has happened to me, have enough memory on your system to literally write a character to the stream. This happens to me very often on, you know, VirtualBox instances where I'm not able to write out characters to the console, and I'm wondering why, and, you know, I've run out of space here. So you can do these sort of checks here on these different things here, as well as, again, if you want to build on top of cout, the abstraction that you have, you can do that. So that's really the advantage here. That's the reason to still have streams. Some folks I've seen say, hey, we've got print line, let's get rid of this. No, this is a different thing here, right? This is a object, and we can build on abstractions on top of it, right? Maybe restrictions for what type of data that you can output and so on. And generally speaking, again, it's relatively easy for folks to just overload the operator here to use streams, although I'd argue, based on my previous videos, it's not that hard to do this with your custom types either. So that's not really a pro or a con. I'm just trying to show you what cout is. It's a global object where we write out buffered output to our terminal here. It is a type of stream. We're going to talk about other streams like file streams and string streams, which are sort of these devices for reading in and out data. And now hopefully you know why we're including IO stream. You know, in fact, we could just have O stream, and you can, I just want to enlighten you a little bit here. Maybe we'll do a video on it, but you can create your own, you know, O stream. You usually just see it as an argument if you're a beginner here, but you could say like my output object here. And then you can do, you know, various operations or wrap this into your own type here in a similar way that cout is. Now let's see what I did do here. Oh, I didn't include, let's see here, stream. Let's see here. Okay, let's compile that. My output object. And I can't just construct it here. You actually have to do a little bit more work here. I think if you look at, let's see, the constructor here, you actually have to put in like the cout. I think there's a read buffer here. Let's see if that just works here. I think this works. I need somewhere where I need to write this out. So I'm just going to ignore that and we'll do a video on it later if we need here. But that's the idea. So that's cout here. And since you know it's an object now, you'll be able to play around with some of these functions here. Yeah, here's that RD buffer, right? So there's a stream buffer that's managing where you're writing your actual information out to, okay? I think that's pretty much it as far as stuff that I want to talk about. If you have other questions, we're going to be doing a few videos, so make sure that you stay subscribed. As always, you can track your progress on courses.msha.io here. If you want to just sign up for free for this particular series, and have a distraction-free environment for checking out videos, you can do that. Otherwise, there's some other courses here that may be of use otherwise. And yeah, let me know. Let me know your thoughts on cout. I'm really curious to hear what the community has to say about now that we have print in C++ 23. That means just get rid of cout. I've heard things as extreme as that, but I think it was just a little bit of a misunderstanding of exactly what cout was, and this idea that because we sort of use it so much, it feels like a function, but we should really be thinking about it as an object. We're overloading that, the two angled less than signs, the angled brackets there, the stream operator overloads for output. So yeah, hopefully that clears up some the picture for some of you folks who just haven't had that. And now you know why it's called cout, character output. Again, so if you haven't seen that in the CPP reference, it's very, very useful. Anyways, folks, thanks for your time and attention as always. Hope you enjoyed this video, and I'll look forward to seeing you in the next one.